On a 2-3 with some rates and some proportion. A unit rate will be a lot of questions at the beginning of your homework today. We're going to kind of clear that up. A unit rate is when the denominator is 1, and just a plain Jane rate is just when they like write a fraction out of these. So let's kind of dive into this. They say, hey bro, find the unit rate. You bought 10 pounds of potatoes for $4. My thing is, check out the labels, pounds and dollars. Are you kind of cool that those are the labels in that situation? You could write this rate either way. You could do it pounds over dollars, or you could do it dollars over pounds. In the real world, since that's kind of what this class is about, a little real world mathy stuff, you know, which label makes more sense to you? Pounds per dollar or dollars per pound? I personally like dollars per pound. Are you with me on that? So what I did was I first set it up as dollars over pounds, right? So $4, they told me that, over 10 pounds. And then whenever they want a unit rate, it's kind of crazy. You just use your calculator. The denominator always has to like have a 1 with it. Like that says 1 pound down in the bottom. That's what a unit rate is. How did I get 40 cents? I literally just punched it in, 4 divided by 10. Why did I do 4 over 10? Because that's what my fraction was. It was $4 for every 10 pounds. You kind of cool with where I got that stuff from. But the labels really make a difference. So when they say find a unit rate, you would do that. Now, if you chose to do it the other way, there's nothing wrong with it. You don't have to write it down if you don't want to. But I think 2.5 pounds per dollar just doesn't make sense in my head. Like in the real world, it's like, no, I want to know how much it is dollars per pound. It's 40 cents for every pound of potatoes that you buy. So that's what I chose to do it. Let's try number 2. Find a unit rate. Joel ran 1,500 meters in, oh no, welcome to your Monday morning, 6 minutes and 45 seconds. We got to like kind of put that all in minutes. How much of a minute is 45 seconds? Do you guys know? Is that like a quarter of a minute, a half of a minute, 3/4 of a minute? Like, isn't it kind of like 3/4 of a minute, like 45 seconds? So what I did was I did 1,500 meters over 6.25 minutes. And then we're going to punch that in. We're going to just punch that in. You just literally punch those numbers in. 1,500 divided by 6.75. And it's kind of a weird decimal. We'll have to round how the homework tells us to round. We're getting better at reading those details, you know, round how they say. But I rounded to the nearest tenth, about 222.2 meters per 1 minute. That's a unit rate. Unit rate. A robot traveling at 25 millimeters every 5 hours, based on that given data, calculate these unit rates. So they'll do this on homework. They'll have you do it both ways. How many millimeters per hour? So what I'll do is I'll start with 25 millimeters per 5 hours. You see, like, the way I did it was whatever they listed first goes upstairs in the numerator. Whatever they listed second goes downstairs. And then you can divide that out and make a nice little unit fraction of that. That is 5 millimeters every 1 hour. Millimeters per hour. When they ask you to do it the other way, you just flip everything upside down, right? They say hours per millimeter, so that would be 5 hours for every 25 millimeters. And the labels make a difference. I know a lot of people don't like to show work. Make sure you show the labels. It makes a lot of difference. And then the weirdest part is a lot of people are going to want to put like 1 hour per 5 millimeters. That doesn't work for a unit rate. You know why it doesn't work? Because the denominator's not 1, right? The denominator's not 1. What you do is you just divide it out. 5 divided by 5 divided by 25, you get 0.2. So we'll put 0.2 hours for every 1 millimeter. The weirdest part about a unit rate is that the denominator has to be 1. Which is actually kind of nice because you let your calculator do all the work, you know. So please note the difference. These guys are rates because the denominator is not 1. These dudes are unit rates. So you don't have this on your worksheet, but I literally just like snipped this out of homework to see if we can get a little help with it. It says determine whether this is just a rate or a unit rate. So a car travels 72 miles in, boom, that right there has to be 1. Is that a 1 or not? Not a 1? What do you think? Rate or unit rate? Unit rates have a 1 down there. Rate or unit rate? This is a rate, right? It costs $6.50 per ride. Are you cool that there's just like a 1 in front of the ride? Is that a rate or a unit rate? That's a unit rate because there's a 1 right there. 5 cups of walnuts for every 2 cups of raisins. What do you think? Rate or unit rate? That's a rate because that's not a 1. 314 items in 5 hours. Rate or unit rate? Rate. $9 per hour. Rate or unit rate? Do you see that there is like a 1 in front of that? There's not a number, so that is a unit rate. $9 per hour. The copy machine can make 65 copies per 1 minute. Rate or unit rate? That is a unit rate. If the second number is a 1, that's a unit rate. Thank you. Now let's step it up. What struggles for a lot of people is reading. Don't forget, I will help you read these if you need help reading them. But they want us to like solve these little stories with a proportion. You've done these long time ago in your algebra classes. Here's what makes it happen. Labels. If you do the labels, we're going to rock it. And how do you solve? Little thing called cross multiplication. So follow me in this first one. A recipe calls for a 1/4 cup of vanilla for every 3 eggs. How do you feel about right here? This stuff right here is like some sort of rate that they have given us. What we'll do, and you'll need to do this, is set up a little fraction with labels. I'm not a big fan of like true fractions inside a fraction. How about we change that to a decimal? What's 1/4 as a decimal? 0.25. And then I need a label on it. What is that 1/4 representing? There's a couple of labels that are off like possible, right? But what's it about? Cups is fine. What's one other word that could be besides cups? Cups is totally fine. What else could it be? Vanilla. Are you cool? Like that's the gist of what's going on up there. It's a 1/4 cup of vanilla. So I'm going to put van, if that's all right with you. If you put cup, there's nothing wrong with that. And then that's for every 3 eggs. I don't think there's a question on what that label should be. It should be eggs. Are we okay with that? You see how that's like a rate that they have given us, and I put the labels next to it. What a proportion is it's 2 fractions equal to each other. Right? 2 fractions equal to each other. So put an equal sign in the middle, and here's the rule to make things, here's a cool word, proportional. Right? For a proportion to work, if the first fraction is vanilla over eggs, the second fraction has to be vanilla over eggs to keep this thing nice and proportional. So I'm going to go and put the labels before I even get started. That keeps us nice and mathematically all good. They give us one other number right here. Mary used 2½ cups of vanilla. Where do you think that 2.5 should go in this red fraction? Upstairs or downstairs? It has to go upstairs because isn't it about vanilla, right? So it matches the label. Are you with me on that? The weird part for people is they don't know what to put next to eggs. That's where algebra comes in and uses something called a variable. You're pretty like handy with x, you know what I mean? So how about we just call that x? Like we don't know how many eggs that is. Rock on? So the main thing is set the fractions up with labels, and vanilla over eggs has got to be equal to vanilla over eggs. Do you remember cross multiplying, where you take like this number times this number? Forget about the labels now. What's 0.25 times x? 0.25x. Bring an equal sign down, and then grab a calculator, and you need to take 3 times 2.5. Right? 3 times 2.5. And could you tell me what you got on that? 7.5. Are you guys okay with that? So I solved that proportion by cross-multiplying. The labels just kind of disappear at this stage. And now we need to solve for x. This is 0.25 times x. To get rid of times 0.25, you're going to divide both sides by 0.25. And those will cancel. And then this will come down. Sorry, that's not what I wanted. But 7.5 divided by 0.25. What you got? Get 30 back. Then you got to have a label on it. And here's the easy part. What's the label? The same thing that's next to x up in your proportion. 30 what? 30 eggs. And if you don't feel that that is realistic, that is very realistic. Recipes is one of the most popular times to set up a proportion when you're making a recipe and cooking stuff. Cool? Hey, just a couple more. Here's a weirder one, though. This one's weirder than a recipe. Sam and Bill agree to split the profit in their company in a 2-to-3 ratio. Winner, there's our, like, rate right there, 2-to-3. So what we'll do is we'll, like, start a fraction and do 2-to-3. But I need some labels with it, right? The hardest part about this one is, like, I don't know the labels. It's going to be their names. Isn't one of them about Sam and one of them about Bill in that case? So how do I know which one's which? Because Bill invested more money than Sam, could you tell me why I need to put a Bill down here and a Sam up here? How did I know Bill had to go next to the 3 and Sam had to go next to the 2 when Bill invested more money than Sam? 3 is bigger than 2, right? You know, going in that situation. So let's set it up. If this is Sam over Bill, this has got to be Sam over Bill. And they say Sam made $4,500 profit, so that's a no-doubter where the $4,500 goes. It's got to go next to Sam. Put an X next to Bill, and could you solve that by cross multiplication? 2x should equal 13,500. Is that the right number when you take 3 times 4,500? And then let's divide by 2. If it doesn't come out nice, just kind of round it how the problem tells you, but this one comes out nice. I got 6750. Is that what y'all got on that one? 6750. Then what is it? It's dollars profit. For who, though? The magic word is for who. Is it for Sam or is it for Bill? It's for Bill up in the problem. 6750 problems for Bill. Those were the warm-uppers. Now let's get a little serious, but it shouldn't be too bad. Stop me if you need help on these next ones. But you feel okay with what I did there, setting up a proportion. We're going to do the same thing on these, but we've got to do a little bit of figuring as well. It takes a hose 4 minutes to fill up a rectangular aquarium that is 9 inches long, 10 inches wide, and 16 inches tall. How long will it take the hose to fill up one that's 16 by 24 by 30? Well, they're all in inches. Next time they won't be. Next time we'll have to do converting, but everything's cool. Everything's in the same unit, right? So could you tell me geometrically what it is when you fill something up with water? Is it like area or volume? It's volume, right? We have to find the volume of this guy, and if you need to write this formula down, volume is length times width times height of this dude. So I'm going to set up a proportion. 4 minutes, and let's grab a calculator, and I don't need you to show any work on it. We just got to take the length, which is 9, times the width, which is 10, times the height, which is 16, or whatever order. Those 3 numbers have to get multiplied together. Did you get 1440 when you do that? Let's learn to put the right label on it. It's not just inches. It's inches cubed because it's the 3rd dimension. You took length times width times height. Are you guys okay with where I got the 1440 from? Cool. Set that equal to, if this is minutes over inches cubed, this other guy's got to be minutes over inches cubed. They gave you all this. Grab your calculator and find the volume of that dude by taking the length times the width times the height. So when I took 16 times 24 times 30, I got 11,520. We'll put it down here, and I'll call that x up here. How do we solve this? Cross multiply. Let's cross multiply. So I'm going to take this number times this number. 11,520 times 4. Big old number. 46,080 equals 1440x. And then you'll divide both sides by 1440. It might not come out nice. This one did come out nice. I put a note on my little practice sheet right here. The ones on homework are not necessarily all going to come out to be nice. How do you round? Mathy. Like if it's 0.5 or above, you round it down. If it's you round it up, and if it's not, you round it down. Just you use basic rules of math to how to round. So x equals 32. What? 32 minutes. Should take 32 minutes. So what we talked about is a 10-inch pizza means that the radius, since it's a circle, is 5. I think that's good to kind of like write that down. And you definitely might want to write this guy down. Area of a circle is pi r squared. A lot of people get that confused with like 2 pi r. That's the circumference of a circle. Area of a circle is pi r squared. So one 10-inch pizza has 830 calories. And here's bogus info, stuff that they just tell you to try to confuse you. Like, okay, this isn't from fat. Who cares, right? But then they say a 16-inch pizza is cut into 8 slices. Okie dokie. What's the radius of a 16-inch pizza? Radius is 16 is like the diameter of it, so the radius would be 8. Are we okay with that? They say find how many calories are in one slice. We'll deal with that later. We're going to do the whole pizza. So here's what we'll do. We will say this. First, let's find the area of the little guy. Area equals pi r squared. If the radius is 5, I'm going to do pi times 5 squared. Squaring means you take the number times itself, right? So it's not 5 times 2, it's 5 times 5. What's 5 times 5, baby? If you need to punch that in, great, but it is 25. The area of this one circle is pi times 25, which the correct way to write that mathematically is 25 pi. Been a while since we've done some geometry. Let's find the area of the other circle. I'm just kind of showing all this work. In my opinion, it's okay if you don't show all this work. I'm just showing you what I'm doing. But his radius is 8. So don't I need to do pi times 8 squared? And if you need to punch that in, great. But it's 8 times 8, or 8 squared, which a lot of people accidentally think 16. It is 64 pi. Are you okay with that concept? Those are the areas of those two circles. Now I can set it up like this. So I do my proportion. The first one is 25 pi square inches is to 830 calories. I'm comparing the area of the circle to how many calories it had. Could you do that in the second fraction? And if this one's square inches over calories, so does the other one have to be. We don't know the calories of that other pizza, but we do know its area. Isn't it 64 pi? Now, I don't know this. And I'm going to be super nice. What's going to happen when we do the math is these pi's are going to end up canceling each other out. It's totally going to happen. So if you don't even want to write the pi's down, I'm good with that when we cross multiply. But we need to take 25 pi times x, and if we just get rid of the pi for fun, are you down with that just being like 25x? And over here, 830 times 64. Got to punch that in. I don't know what that is. But the pi's just end up going away. 53,120. Like they'd both have a pi with them, and it would end up dividing out. So the pi's just kind of go away, right? But what do I got to do to solve? Is divide by 25. So I'll take that big number, divide it by 25. And that doesn't come out nice, so we'll round mathy. Do you see how that's like 0.8? Should I round it up or keep it the same? I would round that up. Please read if they tell you how to round, like maybe they say to the nearest tenth, but if they don't, I would round that to the nearest whole calorie in that case. So 2125 calories. Oh, but that's for the whole pizza, right? 2125 calories. I was looking at my answer and I forgot we're not done. That's the entire pizza. Didn't they split it up into 8 equal pieces, right? So how would you figure out one slice? What would you have to do to that number right there? Divide by 8, right? So divided by 8. I'm going to not even round. I'm going to use this number and just hit divided by 8. And that's where we'll go, how about 266 calories in a slice, you know? So I kind of didn't even realize I wasn't finished. Cool. All right, man. Let me know if you have any questions. Have a good one.